Can you hear me okay? Perfect. So my team is part of what we call Windows core team. And the beauty of this team, huge responsibility, but a lot of interesting stuff. Whatever we develop is actually applied to any Windows client product that we deliver. We're part of security and identity team, and my sub-team is actually owning 3 big areas in security. I would say it's holy grail of all security, why it's so interesting. We own cryptography, crypto part, we own PKI, and we own also modern authentication. Modern authentication in our eyes and our thing is not passwords. So anything that you think passwords is not belong to modern authentication. It's already a very outlived way to authenticate users. And we will talk about that a little bit and what we're doing to change how people authenticate to their domain accounts, to their organizations, and to the websites. And my clicker doesn't work. It's OK. Can we fix the clicker, please? OK, thank you. So today's agenda, we will cover 3 different topics, but all of them are actually very related to authentication. The first one is biometrics. As you probably heard already multiple times during TechEd in Madrid and also New Orleans, we're announcing a lot of investments that we've done in biometrics, and we will talk about that, and we will show you really interesting demos. The second topic is something that you probably didn't hear a lot, but it's very interesting areas that I believe you need to learn, and it's what we call TPM KSPs. TPM KSP, as usual, we love our 3 letters acronyms, as you can imagine, is ability for us to store the keys generated by TPM on TPM and create certificates that actually can take advantage of those TPM KSP keys. The beauty of that is that if certificate is user identity and you associate it with the keys that bound it to hardware, to TPM, then you've done really interesting association between user and device. And it's very strong associations that would not be easily replayed. And the third area that we will talk is the 2-factor authentication, or strong factor authentication with virtual smart cards. And I will tell you what we've done in Windows 8.1 and also the whole interesting stories that I have with our Microsoft IT organization and how we're deploying it internally for our 100,000 users and all learning that we made from that. So I hope it will be interesting for you. By the way, anyone deployed or investigated virtual smart card yet? None? Perfect. So we will talk about that. Maybe you will be interested. OK, passwords. Passwords, passwords, passwords. It's very many problems with the passwords. And minimum, I will name 3 of them. Passwords are easily replayable. It means if you type your passwords, any keylogger, very cheap keyloggers on site, you can collect them. You will ship this password overseas, and it can be replayed easily. Spoofing your user and spoofing access to your enterprises and to any website that you want to keep secure. Passwords are actually symmetrical secrets. What I mean by that, if I know my secret and you know my secret because it's symmetrical, then everybody in the world knows my secret. So to protect symmetrical secrets is much more difficult, and it's really why passwords are easily breachable. Users, in addition to that, love to reuse the passwords. The passwords reuse is a very common theme, and it's really why it's users' way to deal with complex passwords. Do you know, it's actually one research was posted very recently that for PIN of 4 characters, users on touch screens using approximately 0.4, 0.5 seconds. To have 10-character alphabetic complex passwords is taking 14 seconds, 1 form, or even more than that. So it's a lot of pain. You need to remember it, you need to type it. So users trying to simplify their life, and to do that, they're reusing the same complex passwords on any site. The reason then it's so easy to breach very, very simple site that is not protected. And by doing that, hackers actually will have access to your domain, much more protected assets that you know how to actually secure. But it doesn't matter, because if the password is the same on both sides, your security, your protection is actually equal. Protection of this site is, again, shipping shoes, 6M site that was actually hacked very recently. So the point is that passwords are very dangerous. And the last thing, it's replayable, it's breachable, and it's phishable. What I mean by phishable, our users ask to pass and type the passwords every single time. Anything that look like, or smell like, or feel like sign-in page, users type the passwords. They don't even ask any additional questions. And the reason then that any message box that looks like sign-in page can collect users' passwords. So what we do about that, and this is a session about this. So first of all, a few interesting quotes. Facebook. All of this is 2013, by the way. 9.8 million users on Facebook. Their account was accessed by unauthorized user. As a result of that, their identity was stolen, they were defrauded and humiliated online. It was interesting research that published by Deloitte in 2013. Incredibly interesting. 6 million user-generated passwords that they investigated. And they found that out of those 6 million passwords, 10,000 of the most common passwords that you can find online easily are used for 98.1 transactions. It means those common 10,000 passwords that you can easily find, you don't need to hack the system, are used almost for every transaction that users do, accessing organizations, domains, anything. It's what is happening. And the last interesting statistic, we've been told all the time when we are trying to stress the point that, my God, the things are very seriously broken with passwords. Usually small organizations saying it's not about us. There's a recent research that's done by UK. They published that set of sites and organizations, small organizations, are actually hacked in much faster pace. And the amount of really hacked organization, as Chris probably mentioned, is much higher than you would expect. The large organizations, they already hacked so badly that the data on the number is not increasing as fast, but the situation is very, very bad. So with all this gloomy news, we need to find some solutions for you. And we believe that biometric and biometric fingerprints will help us to get out of the passwords. What we learn, you can't increase security without improving usability. And we believe that biometric and biometric fingerprint sensors is actually something that we can improve, incredibly improve usability, ease of use, and provide more secure access to our users. Because they don't need to remember the passwords, they don't need to reuse the passwords, they don't need to do that anytime. And with their biometric sample, we can actually associate much stronger things like certificates, like keys, that is not symmetrical. So let me walk you through what we've done there. Typing passwords is very familiar for you. And again, imagine typing passwords on our touch screens. So when we're talking about biometric, today, in few laptops, not so, again, in 11% of all laptops shipped by Dell, HP, Lenovo, we have swipe sensors. Some of you probably use them. Can you raise hands who were experienced? Wow. I am sure that those sensors that you experienced didn't have the concept of ease of use. It most likely was swipe sensors that were, again, embedded in those systems. So swipe sensors compared to touch sensors that we introduced with a few companies, and we announced in New Orleans companies that called fingerprint cards. We have a representative with us today that actually delivering those touch sensors or area sensors that will provide ease of use that we're talking about. The second company that we also announced in Madrid is Validity. It's also companies that are doing touch sensors. And I have those two sensors with me. It's still very demo-ish, so please be with me. I hope they will work, but the concept is there. So why swipe sensors are not something that we're looking at? Swipe sensor is working on the mode that it's actually taking the stripes. When you swipe your finger over this very, very thin stripe, it's taking your image, and it has only one chance to take this image. And after that, it's compose this image and trying to extract what we call features or minutiae from this sample. When you have touch sensor and you're touching the sensor with your finger, there is no need to do all these things. You can take as many images of your finger as you like, and it's, again, 3D images that allow us to detect much more things about this finger sample. Is also we want to detect the liveness of this thing, so it will not be spoofed by any plastic or rubber finger. Okay, so let's figure out what we try to do in Windows 8.1. It was 4 goals for my team that we put for ourselves, and I think we accomplished them. The first, we want to ease users' struggle of typing those long passwords on their touch screens. The second, we wanted to introduce a new type of sensor. Maybe I will go out of the order, sorry. New type of sensors, not swipe touch. Those sensors that users don't need to force themselves to work with, those sensors will work for user, not user will try to learn how to deal with this machinery. We also wanted to introduce all experiences around biometric fingerprints, all embedded in the system. So everywhere where you will go to type your password, you will have ability to touch the sensor if the sensor exists on your system. So we biofy the system all over the place. But we didn't finish over there. We decided that all those first-party experiences that we delivered in the box, we need to ensure that the same experiences our application developers would be able to leverage. So we expose APIs that will allow those developers to use what we've done in the box. We'll talk about that. So the second thing what we've done in Windows, what usually when we're coming with ideas, we're testing this with users, a lot of users that had some background in IT, those that consumers that had never seen biometrics in their lives. And overall feedback was very positive. People believe that biometric fingerprints will solve this password mess that we are in. It's very convenient. And also, the one interesting thing come out of those user researches is that if we will have this additional thing for user, when user for high financial transaction would need to consent using this sensor, it doesn't feel like something on the way. It's so integrated into experience that they believe that it's actually welcoming. They have control over those transactions. So it's really how our Windows biometric system looks. Let me start from bottom, and I will walk you through these things up. So we have hardware, and its sensor is the sensor that you can see. Our vendors that produce sensors need to provide what we call WBDI driver, Windows Biometric Device Interface Driver. This driver is the low-level driver that talk to sensor, and it can do this talking over 2 buses that we support, USB or SPI. The SPI bus is actually more efficient for us because it's much more power efficient, and it allows the bandwidth that we need when sensor talk to the host. And this communication is happening. On the next level, we have what we call Windows Biometric Framework. And Windows Biometric Framework is actually a unified set of APIs. It's UMDF, User Mode Driver. And it's a unified set of APIs that actually consist of 3 different, we called it biometric units. One of them, it's called sensor unit. And it's actually a set of APIs that translate WBDI driver communication to the sensor to something that everybody on the top would be able to understand. The second one is called engine adapter. Engine adapter is a very interesting thing. Yes, please. It will be possible, but it's again, it will take a little. This protocol is not actually published. WBDI protocol it's unique to every single manufacturer. So again, our WBF framework, it's a set of APIs that actually translate it. On the bus itself, it's very difficult to reverse engineer this special protocol. However, if somebody would like to do that, sensors have ability to encrypt this traffic or to authenticate to the host. So it depends on what we have. Usually, this communication might go. It's up to sensor vendor to ensure that their sensors are secure. And as such, again, we have different mechanisms to ensure that this is happening. But very good question. It's one of our threat modeling. We have this in our threat modeling document as well. OK, so moving forward, engine adapter. Engine adapter is a very interesting piece. And engine adapter is actually where the most IP of those companies is implemented, is the matching algorithm. As you can imagine, the first thing what happened with fingerprint sensors, they take the sample, they create template. And after they create this template, every single time you touch your sensor, they compare the image or acquisition of this image that they made with the template that they already have to figure out that it's match. This match is done based on number of features, points that they extract initially from your template. It's actually an interesting fact. In the court, to convince somebody that you actually created this and in this crime, it's sufficient 12 matching points. Our sensors are capable to match 21 and more of those points. So the ability for us to match the image very closely to your personal image is actually very amazing. OK, moving forward, Windows Biometric Service, it's something that actually running in, again, brokering high IL, what we call intermediate level OS functionality. We have Windows Biometric Client APIs that communicating with Windows Biometric Service and Windows RT APIs that our Windows Store apps are using. In addition to that, 2 pieces that we also have in the box. It's biometric credential providers that are responsible for your sign-in experiences and your enrollment. We call it fingerprint management application or enrollment applications that integrated with modern setting. And I will show you where it's belong. So when we introduced biometrics, we learned a very interesting thing. So if you have on your non-domain joint devices mail app with Exchange accounts that you are enabling for those users, you're most likely using what we call EAS policy. EAS policy is Exchange Active Sync policy. In some of those Exchange Active Sync policy has provisioning for convenient logins. It happens that biometric fingerprint was qualified as convenient login. We're very happy about that, but the problem with this, we don't want to change and make it too complicated to our admins trying to take it out from this convenient login EAS policy. So what we've done quite significant changes to those EAS policy, and those are changes that I want to explain you. So if you have sign-in experience, we will respect EAS policy, and depending on if your bit locked driver, if your drive is bit locked or not, we will store those credentials on the disk or not. But the most important for us was to ensure that even sign-in experiences are disabled, but all consent or user confirmation experiences still will be working. That has nothing to do with user authentication. So we enable this functionality, and we ensure that when you enroll, users understand what does it mean. All GP policy updated appropriately, so you don't need to go and trying to do GP edit and change some policy and find how things will work. It's all will be enabled as soon as you will run your fingerprint management application out of your modern setting. OK, let's go to the demos. And demos is 5. Two seconds. And my machine fall asleep. OK? OK. Let's go to our demos. So first thing that I want to show you is your experience, how you would be able to enroll into fingerprints. Before I will do that, and before I will show all your demos, I want to show you two interesting pieces of equipment that I will be using during my demos. And because it's not possible to show it all together, I will show it separately. So the silver box is a touch sensor that's connected right now through USB cable produced by a fingerprint card company. And the idea is that it will not be hanging out of my USB cable. It will be embedded on the board. So it will be exactly as you would see today's swipe sensors on those systems. The touch sensors will be available over there as well. The second one looks like black brick. This one is actually the demo sensor from Validity. Both of those sensors are very, very thin set of polymer capacitive sensor. And it has ability to do liveness detection. And it's very, very interesting new development that happened recently with those companies. So we're very pleased to announce those two companies, and more companies are working on similar technology that will help us to put those sensors to Windows devices. So to enroll, let me switch to my demos. So to enroll to my fingerprint, I will go to Accounts, Sign-in option. OK, sorry, let me try one more time. I will go to my accounts. And I will try to add my fingerprint to this account. Because I already enrolled my fingerprint to this account, to do that, again, I need to authenticate myself. And let me authenticate myself. And then I need to collect a few samples of my finger using one of the sensors. So I will try to use the sensor. And it says that I need to use different finger because this one is already enrolled. So let me try different finger. And it's done. So two types. If you would enroll with your normal swipe sensor, usually it will take you 6, 7, 8 attempts, maybe more. I can even demo it to you. I have this another sensor in my Lenovo laptop. Let me to show you the difference. OK, I will use different finger in this case because we remember all your fingers and you don't have too many. And I will try to use my swipe sensor here. So it will ask me to check if ensures that my sensor is clean. And even me working with this technology for quite some time, it's taken some. You see? it's taking time. Let's not complain. It's what we have. But new sensors coming, and we believe that it will be better. So the scenarios that we enable with these sensors is amazing. So let me show you a few. First of all, one of the features that we called Touch to Buy is related to the way how users can buy their application in the App Store. Have you seen it? Anyone? No? Then I will show you. OK, so you go to App Store, and it's beautiful App Stores that we rebuild for these things. And I can go to any apps, and I will start with my paid app. Let's pick something really expensive. Something really expensive. I don't see too expensive. OK, $9.99. How does it look? OK, when I'm going to buy this app, and I confirm my purchase, as you can see, my fingerprint is requested to go and buy this app. And the beauty of that your kiddo that knows your passwords would not be able to authorize those purchases. Because it's not only login user that needs to confirm this purchase. It's the only user that actually his financial instrument, their card, again, any credit card is actually submitted to App Store to buy those apps. So I will allow the purchase. And I didn't add my card there, because otherwise I will finish with billions of apps that I don't need. But you got the point. So we didn't finish right there. We also believe that any app, if they have in-app purchase transactions needs, can use the same functionality. So I put this Print for Kids app, and it has the ability to have some paid drawings. Let me go to some paid drawings and buy them. And yet again, it asked me to confirm this purchase. So our developers would be able to ensure that only them would be able to deal with that, and not somebody randomly choose to buy these apps. So we also made sure that the same experience is happening as you will go and, again, run some apps that required you to authenticate. So this app is actually a remote app, remote desktop app. And you would be able to connect to your organization. I'm trying to connect to my Redmond machine here. And it's, again, will ask me exactly, instead of providing my password, it will ask me to touch sensor to authenticate my operation. Additional things that I want to show you is ability for us to, again, this one is Windows SDK. We have two. I will show you all demos, and after that conclude with what does it mean. We expose two different APIs. One of them is to check availability, and the second one is to ensure that user will be asked for consent. Check availability, including all complexity of dealing with if biometric sensor is present, if user that login is actually enrolled. All of that is hidden under this one very simple API that you can call. And if you will check availability and we will return yes, as I will do here, and the output will return yes, we have user consent, then the next call you can do and request this consent and even write something to the user. And again, user will be prompted to authorize this transaction again. OK? So now we created some interesting app that show you these APIs in action. And it's, again, demo stock app. So previously, what I would need to type enormous password to every single time to enter to this app. Moving forward, all what I can do, I will type the password 1, associate it with my fingerprint. And from this moment on, when I'm signing into my app, it will ask me to do something, and it's what I will do. And I will scan my finger. And if I would decide to do some high-value transaction, say I decided that my Contoso, this very interesting company, has very good stock price right now, and I need to sell all their stocks to get really, really rich. So what I will do, I will sell those stocks, but I want to ensure that it's me selling those stocks, not my kiddos that simply have ability to share my session with me. So when I will do that, I will actually sell the stock, associate my touch with this, and the stocks will be gone. So, and I hope I will get this really big money soon. Okay, so the point that I was trying to make, let me go back to my slide and summarize it very quickly. So user consent verifier, we believe that it will help you in multiple things. It's not only to authenticate users and deal with authentication, but also we've seen necessity and seen a lot of apps in different stores that doing what we call cloaking. Cloaking is ability to control your data. Say you have all those pictures in your app and you don't want that everybody will see all the pictures. Maybe some pictures are too personal. You can cloak those pictures, so ensure that user only will be able to see those pictures when it's real users that are operating this machinery. So all of those things will be very useful, not only for high-value transaction thing, but also for something to keep user privacy intact. So this one is our yes, please. Can you speak a little louder? So the question is if those functions are available to all OS SKUs, I think, it's what you're asking, or it's for specific SKU. It's available for every single SKU. We are not SKUifying our APIs. Okay, so there's, as I said, two APIs. It's very simple. It's actually 2 lines of code. Even our big managers would be able to write it, so I'm sure you would be able to go through that. And we've seen the demo, and let's move to the next topic. Next topic will be a little heavier than biometrics, but I'm sure you will enjoy it as well. So we will talk about hardware or TPM attestation. And why TPM attestation? So in Windows 8, we enabled what we called ability for us to generate keys using TPMs. And TPMs are very interesting and very valuable asset, and it will be available on every single machine starting from 2015. Today we have TPM 1.2 and 2.0 on some machines, and we believe that every single PC very soon will have TPMs available. It's actually logo requirements that we are pushing forward. So what we enabled ability to create those keys and certificates using TPM capability. But also we changed the template on Active Directory Certificate Authority Service, where you can, as admin, you can say, based on this template, generate for me certs that would be associated with those keys that will be using TPM KSP. Immediately after a few companies actually started to deploy Windows 8 over there, we received very interesting 2 questions. First, how we will check that client doesn't lie? And the second question was how I will limit set of TPMs that I will trust. I don't want to trust every single manufacturer. I want to trust only a few TPMs that I can validate the processes and ensure that only certificates and keys from these TPMs is what I trust. And when I'm talking about client lying, is actually a very interesting truth that nobody told you, I guess. When you have on your template 2 requirements, you can put your certificate saying non-exportable, or you can say store on TPM or encrypted by TPM on the disk. Nobody told you that you have no chance to validate it. If I have raw client, this client said, yes, sir, but by the reality, it will not store it on TPM. And it means that Mimikatz or any other tools would be able to lift those certs and keys very easily because they're not TPM bounded. To solve this problem, we introduced TPM KSP, and to solve the problem of how we will ensure that client doesn't lie, we have the concept of TPM key attestation. TPM key attestation is enabled between two products. One of them is Active Directory Certificate Authority Service. It's shipped with Windows 2012, whatever name we will come up with, RTM, I think, and the Windows 8.1. With two of those products, you have very interesting capabilities that we call TPM key attestation. So let's talk about that, but I will explain you slowly in details, but if you have any questions, please be with me. So a little bit about TPM. TPM has, when it's manufactured on the floor, it has what we call EK. EK, it's called endorsement key. Endorsement key is something that manufacturer actually infusing into TPM to create this trust anchor that everything started from, because we need to trust something. Those EK keys are always present. The problem with EK, they absolutely unique for this system. It means if I will present your EK keys to any random sites, you can track me across all those sites, because it's EK that as GPS, as your location service can point back to your device. It's really why the second key is actually used for attestation. It's called Attestation Identity Key, or AIK. It's exactly the role of this key is to hide the identity of EK. EK only alone who can create EK keys, and those two are related as, again, father and son. So additional things that we're working really closely with TPM manufacturers, we want to ensure that they will infuse not only EK keys, but also EK cert. EK cert certificate is much better, because if you want to trust those particular TPM, you can trust the root CA authorities that issued this cert to this manufacturer, and you don't need to collect those specific keys. So it's, again, are you talking about hierarchical trust or key trust? Okay, so how certificate enrollment work with TPM key attestation? So we have Bob, and Bob has TPM capable machine. And we have certificate authorities, ADCA service, that actually going to issue certificate to Bob. And certificate authority collected EK pubs from, EK pub is EK public part of those endorsement key. So they collected it using our PowerShell commandlets that we're shipping in the box. So they have this white list of manufacturers that they trust or devices that they want to trust. And it's incredibly interesting opportunity for BYOD devices. If you will look and you have some asset management for those BYOD devices, you always can collect those EK pubs using the same PowerShell script as I have in this particular case. So we have those wonderful keys. And it means when we, as client, ask to create certificate, we are submitting what we call certificate request. As part of this certificate request, we ask in TPM to generate AEK key. And it's actually not permanent key. It's ephemeral. We do it only and only for this transaction. And we also ask to generate what we call RSA keys that by the end of the day will be associated with the certificate that we will need to ask our certificate authority to provide for us. Okay, so what we do, the first step, we take in the very interesting package. We take in our RSA public key, and we sign it with AK public key. And we, private key, sorry, and we added AK public key to the package. After that, we sign the whole entire package with EK private key and included EK public part to this package. And with our certificate request and all other certificate property, we send it to CA authority. What CA does for us is validate this EK pub in their whitelist and say, yep, I know this EK pub, I can trust it. And it also breaks the package and validates that all cert and all functionality, all keys that we added to this package is actually the right keys, because you can validate your signature with your public key when it's signed by private key. And then our certificate authority generates the secret, saying, OK, here's the secret, my dear client, and it's signed it with EK pub. And it means only clients that has possession of EK private key would be able to decrypt this package. So it's exactly what we do. If client is not raw client, is asking, loading this package to TPM and saying, dear TPM, can you please decrypt this package using your EK private key? It's decrypted, we're taking this blob and sending back to our authority saying, here we go. Now you know that I have this particular thing decrypted because I own this EK private key. And as soon as this package received by certificate authority, those guys saying, yep, we validate the secret, it's matched. Now we know that you really have this TPM, you attested to me cryptographically that you own this TPM and this EK private key is in your possession. And they're issuing certificate for those RSA keys. The beauty of that now user identity is actually tied to this device. And by tightening and hardware bounding user identity, if user will use this certificate, you know that from this device, it cannot be replayed. It cannot be lifted. And how it can be used, let me go to the next case. I have Bob, the same Bob, with TPM attested cert. And I have Alice with, again, maybe poor Alice doesn't have the right hardware, PC doesn't have TPM. And we have the same certificate authority. So Bob and Alice asking to requesting the certificate and receiving those certificate. And only Bob was able to attest that his certificate is actually associated with the keys that really bounded to TPM. With all of this in mind, they're receiving different type of cert. So the beauty of that, after TPM attestation will be done, we putting special magic number, magic policy in the cert, saying that this cert went through all TPM attestation. And after that, radio server or VPN server is actually respect this policy. It has ability to look in specific OIDs or policy and say, only those guys that have this TPM attested certs would be able to go and connect to my network. And those, sorry, Alice, who doesn't have ability to TPM attest the certs, they would not be able to connect to my very well-protected network. So let me show you these two certificates. It's how you would see the difference between them. The one certificate is the one that is not TPM attested. The second one has OIDs associated with every single operation that we do. So we validate EK endorsement key. We validated key certificate, and we validated the endorsement key as actually TPM attested. Also, we have 3 different modes that we can do TPM key attestation. One of them is on first use. On first use, it means that user will connect with domain credentials, username and password, and after TPM attestation will be done, we accept that. The problem with this model is that you don't have any control over what TPMs you trust or what you don't. The second model is called whitelisting EK pubs, when you collect the set of EK pubs and allow only those that you trust. And the third model using EK cert. Okay? So let me walk you through that operation. So you install certificate authority service, and you go to the MMC snap-in. As usual, you will choose certificate authority, certificate templates. And you will go with template. Let me go back one step. I pushed too many buttons. It's called V4, schema V4. And you will go to properties. And in the property, we added additional tab. It's called key attestation. So on key attestation, you can decide if you want key attestation, or you will continue to, again, issue your certificates based on standard policies that you had in the system. You have key attestation types that you want to enforce using user credentials, as I said, or endorsement certificate or key. And you have opportunity to include your OID or not into certificates that you will issue. Okay? So talking about certificates, we've done a lot of work to make certificates much more friendly using WinRT APIs, and few of our own applications are actually taking advantage of that. So prior to that, in Windows 8, you didn't have on WinRT, on modern apps, ability to even create certificate as an object, filter those certificates, do anything with them. So we introduced in Windows 8.1 all set of APIs that allow you to create certificate object, define maybe what again, algorithms you want for this certificate to be done. You want to have filter those certificates, you want to validate those certificates, build chain, everything that you need to do. So two apps that actually immediately took advantage of that, it's our Mail app. Mail app, when it's doing Exchange sync server with Exchange account, it's using mutual authentication, and it means it needs to have a special certificate for users that they change. They use the WinRT APIs to create certificate object and filter this certificate so users don't need to use certificate picker to choose the right certificate. The same with VPN app. We have WinRT VPN app. And as you probably know, when you're connecting to any VPN endpoint, VPN server, you're using RAS service in between. And VPN app, it's enumerating all certificates that they can use for this particular user and selecting the right certificate. So they're also using the same API that I'm talking about. Here is a snippet of this API, how you would be able to filter certificate and choose certificate, say, for friendly name. There are plenty of other filter properties that you can choose based on algo, based on, again, your UPN, user principal name, etc. So all these documents available in MSDN already for 8.1. If any of you interested, please go and look at that. And the last piece on certificates, we implemented a new type of certificate enrollment protocol called Simple Certificate Enrollment Protocol. The beauty of this protocol, it was actually a very old protocol used by 10 years in routers. It has very significant issue with user authentication. We fixed that with 2012 server and DAS and client, and we natively support this protocol. It means that for all your non-domain joined devices to enroll in certificate becoming very easy and very straightforward operation. Also, any MDMs that working with non-domain joined devices actually support SCAP, because Apple for years also supporting SCAP as their enrollment protocol. So anyone that's working on mixed environment between Apple and Microsoft devices would be able to utilize that. And this is the last topic that I want to bring to you is our two-factor authentication. So prior to that, we talk about biometrics. Biometrics is also its single-factor authentication. When we're talking about TPM, KSP, and TPM certs, we're also talking about strong hardware-bound single-factor authentication. So now I'm moving to the next level and talking about two-factor authentication. So when we're talking about two-factor authentication, the things that everybody immediately remember is physical smart cards. Physical smart cards are great. They're really great, and my team owning them as well. But the beauty of that and the trouble with them is that you need to have a lot of expenses to put this in your enterprises. It's a very expensive thing. For people that already deployed physical smart cards, they kind of moving along and taking advantage of that. But for those that don't, it's very complicated to get it up and running. It's also required additional hardware. You need to have the smart card reader attached to your machines. Imagine the beautiful surfaces that I hope some of you purchase with all this long cable hanging around that you need to put your smart card in. So to solve this problem, we decided that this one is actually very familiar to you, but this one would be even better. So imagine that your device is your physical smart card, is what we call virtual smart card. We're using TPM on those devices, and all of those devices and very many more actually are TPM capable. And we're using TPM to create the same functionality as you would have as your physical smart card. So what we do, we're using three very important functionality of TPM. It's called non-exportability. It means nothing that you put on TPM cannot be exported. We're using isolated crypto. It means every operation that we do in the certificate on virtual smart card, would it be encryption, decryption, signing, signature validation, all done isolated from OS. It means malware would not be able to get access to that. And the last thing, it's anti-hammering. Anti-hammering functionality of TPM allow us to ensure that we can block this virtual smart card before users would try too many times, too many pins. So with all this functionality, we added this, what we call virtual smart cards, to the system. And first time in my history in Microsoft, people were standing in line to enroll in their virtual smart cards. So as you probably know, every Microsoft T received Surface when we issue Surfaces. And as a result of that, with this Surface to get access to your corp, you need to have virtual smart card. So we have 100,000 people starting to yell on my team where and how to provision those virtual smart cards on our devices. So it was a very interesting experience. We learned a lot. And the result of this learning we bring to our Windows 8.1. So first what we learned, and it was very interesting actually, that our provisioning experience was very bad. And can you imagine all your execs yelling at you? So I'm on a laptop. Yelling at you that they need to click too many times and do too many things and actually to enroll in this virtual smart card. It's absolutely not something that you like to have. So as a result of that, in Windows 8.1, we enabled a lot of APIs, WinRT APIs, that help us with provisioning. So you don't need to go with some ActiveX control and do some crazy stuff with your virtual smart card. You can provision your virtual smart card as modern app. There are very interesting challenges with that, and I will talk about, but let me walk you through that. So imagine that I need to create my virtual smart card, and it's, again, demo app. Please be with me. It's not the final app. The idea is that we created WinRT APIs that multiple products taken already advantage of. The company called Interseed is actually going to have the full set of services that allows them to manage virtual smart card. And on Microsoft, we have what we called FIM team, FIM-CM teams that are also building their own app to provision virtual smart cards. So again, as usual, we have fingerprint to authenticate. And I need to type my PIN. And again, the policies that we have, by the way, we also added policy control and PIN complexity control to virtual smart card, because on physical smart card is actually coming in place as part of physical smart card secure element, but because it's TPM, we added this functionality on top of that. So it will take a little time, and I will actually move to my slides for a moment, and we will come back and check on these things. And the reason why it's taking time, not because I want to hide it from you. I have TPM 1.2 on this machine, and it's very slow. On Surfaces, we have TPM 2.0. It's incredibly fast, so it will take probably a few seconds. Here, it may take a minute. So virtual smart card is actually allow us to do very interesting thing. It helps us to do local domain account access as two-factor authentication, because something that I possess, it's my device, and PIN that I provide. So it's two-factor authentication that we delivered right from your device. Remote access, as I will show you there's a demo very soon, will allow me to connect back to my organization. It's also ability for us to do RDP remoting. If you, in terminal server sessions, you today can use your physical smart cards. We designed our virtual smart card such way that anybody will not see any differences. So for them, it's the same physical smart card as they had before. And it means everybody that used physical smart card before would be able easily to move to virtual smart cards. We allow, again, certificates that do signing, as MIME signing on virtual smart card exactly as physical. And we also have one interesting feature that probably you didn't know about. You can hold your smart card functionality and keys own virtual smart card to ensure that the volume, bit-locked volume, would not be removed from this system. So let me switch to my machine to continue the demo. So the virtual smart card is actually delivered. And to use it, what I would need to do, I would need to go to my Microsoft IT VPN, and I will do connect. And it will ask me to type the same PIN as I created before. And it will verify my credentials using those certificate APIs that I explained to you earlier. It's doing it very slow, but that's it. I'm connecting back to Redmond. So, and not connecting simply with my domain credentials, I connected actually with my strong two-factor authentication credentials. Any questions so far? OK, so some learnings that we had from our Windows 8.1 virtual smart card provisioning. As I said, provisioning was one of the interesting things. The second issue that we learned is the PIN policy. We learned that every single organization has their own PIN policies that we need to ensure you would be able to specify in your APIs. And the third thing that we learned is actually very interesting. TPM anti-hammering attack is different depending on manufacturer from manufacturer. Some are very forgiving. They can, again, after you will type 12 times, they will start to slow you down and add delay. Some TPMs are actually creating, after 32 mistyped attempts to do your PIN, they actually block you completely, and you would not be able to reset these things. So to solve this problem, in 8.1, what we've done actually, we introduced the software PIN policy. When we, prior to let TPM to block you completely, after 5 wrong attempts, exactly as physical smart card, we block your card. So with all this functionality, we actually made sure that all virtual smart cards are very usable, very easy to provision, and incredibly easy to use. Any questions so far? OK. So to summarize everything that I told you today, passwords are evil. We need to find a way to get rid of them. They're absolutely not safe anymore to keep our users protected. And to ensure that we have some solution to move away from passwords, it needs to be incredibly convenient, incredibly easy to use, so users would be able to adopt it. It also has to be something that's hardware bounded. It cannot be symmetrical. It needs to be asymmetrical. And it's also very important that for some operation, we will use two-factor authentication, and virtual smart card, we believe, is the solution for that. That's all what I have today. If you have any questions, thank you so much. I really appreciate that you're staying with me so long. And it's the last day, last session. I'm so proud of all of you. Thank you so much.